Welcome to this series of the binomial expansion using combinations. We have learned how to expand binomial expressions that are raised to a whole number using the Pascal's triangle. Recall, this is the Pascal's triangle. We said if we want to expand a binomial expression raised to the power 0, we use 1 as the binomial coefficient. We further said if we want to expand a binomial expression raised to the power 1, we use 1 and 1 as binomial coefficients. We also said that if we want to expand a binomial expression raised to the power 2, we use 1, 2, and 1 as binomial coefficients. Furthermore, we said if we want to expand a binomial expression raised to the power 3, we use 1, 3, 3, 1 as binomial expansions, as binomial coefficients, and so on and so forth. I'll also remind you that we said that the second number in the row is equal to the power. So if I want to raise a binomial expression to the power 3, I simply locate where the number 3 is, and the row which makes the numbers should be used as binomial coefficients. Today we will learn method number 2, using combinations. Combinations are used to expand binomial expressions that are raised to a whole number also. Example: a plus b raised to the power n. A plus b is a binomial expression, and if we raise it to the power n, where n is equal to a whole number, whole numbers are 1, 2, 3, 4, and so forth, then we can use combinations to expand this binomial expression. Suppose we want to expand a binomial expression raised to the power 3. First, we figure out the binomial coefficients. For the first term, the binomial coefficient is 3 combination 0. For the second term, the binomial coefficient is 3 combination 1. For the third term, the binomial coefficient is 3 combination 2. And for the fourth term, the binomial coefficient would be 3 combination 3. Notice we are always beginning with 3, 3, 3, 3. This 3 is representing the power. We want to raise a binomial expression raised to the power 3. Notice also that we start counting from 0. So 0, 1, 2, 3. So this number is always 1 less the term. So 1 minus 1 would give us 0. 2 minus 1 will give us 1. 3 minus 1 will give us 2. And 4 minus 1 would give us 3. Where do we stop from? We stop when the power is equal to that number. So in this case we have 3, 3. That's where we stop. So it can't go further than 4 terms when we want to expand a binomial expression raised to the power 3. In the previous lesson, we also learned how to use a calculator to evaluate combinations. So if we use a calculator, 3 combination 0 is equal to 1, and 3 combination 1 would give us 3. 3 combination 2 is also equal to 3, and 3 combination 3 is equal to 1. Example: expand the binomial expression below using combinations. X plus y raised to the power 3 is going to be equal to 3 combination 0, which is the binomial coefficient for the first term. Notice we are using 3, which is equivalent to the power, and we start counting from 0. Then we raise x to the highest power, which is 3, and y to the power 0. Why? Because 3 plus 0, which is equal to 3, should always equal to that 3. Okay, it's a pattern which is being formed here. The second term will have 3, which is that combination 1, so we're counting from 0 to 1, and then the power on x will start reducing by 1, so 3 minus 1 is 2, and the power on y will be increasing by 1, so 0 plus 1 is equal to this one. Notice again, 3 combination 2 is the binomial coefficient for the third term. Again, that 3 is that 3. The 2 here is simply because we're just counting 0, 1, 2. The 1 on the power x, or the 1 on the power 1 on x, is from there we've subtracted 1 to get 1. So all that we're doing on the powers of x, we first start with 3 and we keep subtracting 1. So 3 minus 1 is 2, 2 minus 1 is 1, and the powers on 1 keep increasing by, the powers on y keep increasing by 1. So we start counting from 0. So we've got a 0, 1, 2. And I guess you'd guess what the fourth term will be. The fourth term is 3 combination 3, that 3, 3, 3, 3, 3, and we are counting 0, 1, 2, 3. We're subtracting 1s on the powers of x, so 3 minus 1, 2, 2 minus 1, 1, 1 minus 1, 0. And on the powers of y's, we're just adding 1, so 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 2 is 3. That is how we expand a binomial expression using combination. Next, we're simply going to simplify. So let's simplify this. Using a calculator, we have learned that 3 combination 0 is 1, 3 combination 1 is 3, 3 combination 2 is also 3, 3 combination 3 is 1. Next, we're going to apply laws of indices to finish this, the simplification. We know, according to laws of indices, that y raised to the power 1 is 1. So here we're going to have 1 multiplied by 1, which is 1, multiplied by x3, which is just x3. Here we're going to have 3 x squared, and y raised to the power 1 can simply be written just as 1. Here we've got 3. Again, x raised to the power 1 can just be written as x, and y squared there. Here we've got 1. X to the power 0 is 1, so we're going to have 1 multiplied by 1 multiplied by y to the power 3, which is simply y to the power 3. Okay, now try out the following exercise. Use combinations to expand the following binomial expressions. Pause your video. Make sure that you go through all these, and if you need to reference John Bed 6th edition would be a good place to go to. Thank you.